Hello everyone. This is a video presentation on our course project for the course Pattern Recognition and Machine Learning. Our project title was Face Identification, and these are our group members. Let's study about the problem statement we were dealing with. For the problem statement, we have to identify a face image by classifying it to one of the key classes. For this task, we can extract LBP, HOG, and CNN features and compare different techniques. So what this problem statement essentially means is that we are given an input data, that is an image or a set of images, and on that input data we are trying to implement some models based on some pre-processing and some feature extraction. We'll discuss about pre-processing and feature extraction later in this video. And finally we have to identify the result. And by result we mean we have to classify it to one of the key classes, which may look something like this. So let's study about the input dataset we were dealing with. For the dataset, we have the labeled faces in the white deep funnel dataset. Here, labeled faces signifies that each image is assigned a label of the person whom that image is. And by deep funnel, we mean that some pre-processing has already been done on the dataset. Let's study about some image parameters we had. First of all, the dimension of each image was 250 by 250 pixels, and in total there were 13,233 images, and the total labels were 5,749. So the input dataset might look something like this, and we can see the pre-processing on the tilt and rotation in each image. So let's study about the way we extracted the data. For data extraction, we divided this process into two parts. That is, first we will extract all the image paths in the dataset directory. Finally, the extracted image paths will be used to extract images, which is done by loading the images. Let's study about feature extraction. uh, we have to extract histogram of gradient or oriented gradients, local binary pattern, and CNN features. And the reference code for that was provided by the instructor. And these are the features shown in the images. Let's have a look at the way we reduce dimensionality. Now we have resized each image to 40% of its original size. That is, each image has a dimension of 100 pixels by 100 pixels. That is a total of 10,000 dimensions, which is a lot of computational time. We need to reduce the dimensions in order to make some logical predictions. So to reduce dimensions, what we did was we firstly applied PCA, Principal Component Analysis, on the complete dataset, and then we have taken only those principal components that leads to a cumulative variance of 98%, and then transform the dataset according to the trained PCA model. And on the transformed dataset, we have applied LDA, that is linear discriminant analysis. And finally, the dataset was projected. The transformed data due to PCA was projected along the LDA projection vector. So what this approach essentially means is that we have an original dataset, we applied PCA on it, and the number of components reduced to 606. And then on the transform dataset, we applied LDA and the dimensions were reduced to 18 only. Now, let's study about the classification models we have used. Firstly, we have used naive-Bayes classifier, and the accuracy for that was maximum for the project, which was 82.09%. Then we have used KNN with k equals 5. The accuracy for that was 78.34%. Then we have used random forest classifier, and the accuracy for that was 77.27%. And then we have used support vector classifier with a linear kernel, and the accuracy for that was 78.6%. Finally, we have used an artificial neural network with an input layer of 18 neurons, because we have 18 features in our transform dataset. And then we have passed it through three hidden layers with 200, 100, and 100 neurons respectively in each layer with a ReLU activation function. And finally, we have our output layer with 12 neurons and with softmax activation function. And the output layer is assigned with each label. and the accuracy for the artificial neural network was 78.07%. Now let's look at the demo code. So this is the demo code. It is also provided in the GitHub repository for the course project. And let's test this demo code by let us ask for image path. Please note that the image should be correct. I have an image of Jennifer Capriati in the same directory, so I'll apply that. And we can see that this is the image of Jennifer Capriati, and all the models classify it as Jennifer Capriati.